Hey buddies, my name is Sibusiso, but you can also call me Coach Smu. Welcome into the Maths Buddies tutorials. In today's video, I'm going to be sharing with you a 5-method approach of basically solving general solutions. So what do I mean by 5-method approach? So basically, there are 5 type of questions that you might get when it comes to general solution, and all those 5 questions, they have a different approach of basically getting into your answer. All right. So without wasting any further time, before I get to that, to those 5 approach, please make sure that you share this video with your friends. And also, if there's anything that you liked about this video, make sure that you also drop that on the comment so that I can see what is it that you liked. And if there's any request, make sure that you drop that also so that I can be able to generate that for you. All right. So without wasting further time, I'm gonna go and start straight with the first type of the approach. So the first type of questions that you might encounter when you're dealing with general solution, it is basically when you're given a trig ratio and then it's equated with something, right? So the first thing that you always need to do when it comes to this one, it is you always need to check the nature of the answer that you've given here. So we see here that the answer here is positive. So because of it is positive, it means now we're going to ask ourselves which quadrant do we have 10 being positive, right? So we know that 10, it is positive in the first quadrant and the third quadrant. And the reason for this is because we're going to be using these, right, for general solution, right? So that is where we're going to be finding our general solution. Now, after that, we're going to be calculating your reference angle. So your reference angle will then be your tan inverse of square root 3, right? So now here, you're going to go straight into your calculator. Then you're just going to press that, tan inverse root 3. Then you're going to be getting your answer, which is 60. And then from there, you're going to go straight into basically your general solution. So this one, as you can see, it is pretty straightforward. So here we know that the first quadrant is reference angle. So which means now here what we're going to do here is this part is your general solution. So you're going to say 3 theta plus 2 degrees, right? It is equals to your reference angle, which is 60 plus the period for 10, which is 180 times k, where k is an element of integers. And then from here, you can just solve for your theta. So here I have 58 plus 180k. And then I'm going to divide by 3 everywhere. Dividing by 3, I get theta as, let me see, check out a calculator. It's 8 divided by 3. So that gives me 19,33. So it's going to be 19.3. Let me write this 33 plus 60k. All right, so that will be the first part. Then the second part will be, of course, your third quadrant, which is going to be 180 plus your reference angle over, sorry, not over. So here we're starting with 3 theta as your general solution plus 2 degrees equals to 180 plus your 60 degrees, right, plus 180k. Of course, where k is an element of integers. And then from here, 3 theta plus 2 degrees, or 3 theta rather, is equals to, so here I have 180 plus 60, which is equals to 240. But then now when I subtract the 2 that I take over, it becomes minus 2 there. So 240 minus 2, it becomes 238 plus 180k. And then from here, I'm just going to divide by 3, and 3. Then theta is going to be, so calculator, take that out, 238 divided by 3. And then the answer here will be your 79.33. So it's going to be 79,33 plus 60k. So this is the first type of your general solution that you might encounter. So let's go ahead and look into the second one. All right, so now looking over the second one, we can see that here the nature of this question is totally different or completely different from this one. This one here, we just have a trig ratio with an angle, constant number. But then now here we have 2 trig ratios, sine and cos. So the minute you see sine and cos, right, in 2 terms like that, you can see they are separated. Basically, it means now here what we need to do here is we need to form one single trig ratio, and that single trig ratio is going to be tan theta. So how do we do that? Basically, what you do is you're going to take the one with cos, you take it over across, right? So if you take it across the equal sign, it will be 3 cos theta, right? And then we know here we want to have tan theta, so which means now here left sign, so I mean I need to divide by cos theta both sides. So by dividing by cos theta both sides, this theta cancels with that, and then now sin theta over cos theta, we know that it is tan theta, but this is equal to 3. And then of course here we're going to divide by 2 both sides, and then of course here we're going to have tan theta as 3 over 2. Then again, here tan theta is positive in which quadrant? So we know now here we have quadrant 1 and quadrant 3. Okay, so now from here, the reference angle will then be tan inverse 3 over 2. And then from right there, we're just going to press this in our calculator to get our reference angle. So we just get that. Tan inverse 3 over 2, so that will be 56,31. So it's going to give us 56,31, and of course here we're going to have our first quadrant, and then I'm just put in the third quadrant there. Our first quadrant has a general reduction of reference angle, and then third quadrant is a reduction of 180 plus reference angle. Okay, so now here we see that theta is equals to reference angle, which is 56,31 plus 180k, where k is an element of integers. And then now on the next one, we're going to have theta as 180 plus 56,31 plus 180k, where k is an element of integers. And then after this, we're just going to be adding these two. So by adding these two, we're going to get 236,31 plus 180k, and that is how we basically solve this one. Understand that in both these two things here, the thing here, it is not to focus on what the answer gives me, but it is to focus on the nature of these questions. Hence I said we have 5 types, right? So let's go ahead and look into the third type. All right, so looking over the third type here, we see that we have 3 terms, or we have an equation that has 3 terms, right? And then out of those 3 terms, we have 2 trig ratios, sine squared here, or the one with sine is squared, and the one with cos is not squared. So this is a sign that here we're going to be factorizing, right? But then now, depending on what we get in the end, that's when we can see whether we're doing trinomial or difference of 2 square, or highest common factor, or grouping, or whatever, right? Now, what is the first thing that we're going to do firstly? So the first thing when you're having this type, it is to make sure that you change the one with square, right? And write it in terms of the one that doesn't have a square, right? So what do I mean by this? Here I have I have sine squared, so it means I'm going to change sine squared into 1 minus cos squared theta. Why? Because I want to have cos squared theta and cos theta together. All right, so let's go ahead and do that first. So which means now firstly I'm going to say 5 minus 1 minus cos squared theta. Notice that whenever you substitute, you put a bracket in case there's a negative, because you're still going to be multiplying by that negative. But then here we get this equals to 0, and then this becomes 5 minus 1 plus cos squared theta, right? Minus 5 cos theta equals to 0, right? So now here you can see that if I'm organizing this, I'm getting 4 here, and then I'm getting cos squared theta here, and I'm getting minus 5 cos theta here equals to 0. Now as you can see here, these are 3 terms, which means here we're going to be looking for a trinomial. But in order for us to do that, we must first have cos squared theta minus 5 cos theta, right, plus 4 equals to 0. Now I'd like to also come up with other methods to help things to get things simplified for you, right? If this is confusing you, or you can't see it as a trinomial, all you have to do is to let k to be cos theta, right? And then k squared to be cos squared theta. Why? Because now once you have this, this will then change into k squared, right? It will change to k squared minus 5k plus 4 equals to 0. But then now don't forget to bring it back to cos theta once you solve for your k. So by doing this here, you will then see that here you can easily factorize k by having 1 and 4 minus minus, and then your k is going to be 1, or your k is going to be equals to 4. So basically this means now here cos theta is 1, or here it means cos theta it is 4. Okay, so now once we get here, we'll then do our general solution. Now before we get into general solution, always understand that cos theta and sin theta can never have an answer that is more than 4, right? So basically it means now if I'm starting with that one, right, I know that this answer is positive, so it means I'm expecting to have general solution on my first quadrant and my third quadrant. But then now when I'm calculating my reference angle, I'm gonna get an error, right? Why? Because that value here 4, it is more than 1. So let's just see here so that you can see that what I'm saying is correct. You see there, you're getting an error. So because of you getting an error here, it means here for this part there won't be any solution, right? But for this one there will be a solution. This is positive in the first quadrant and in the fourth quadrant. So let's go ahead and calculate that solution here. So reference angle will be cos inverse 1. So we are going to get an answer there now because we're having 1 there, right? See there, we're getting 0. So this means now the first quadrant, we're expecting to have what? Expecting to have reference angle as our reduction. And then here, quadrant 4, we're expecting to have 360 minus reference angle as our reduction. So therefore theta, right, which is our general solution, is equals to 0, plus the period for cos, it is 360k, where k is an element of integers. And then now on the fourth quadrant, theta, it is going to be 360 minus 0, which is just 360, plus 360k, where k is an element of integers. All right, so that is the third part. So let's go ahead now and jump into the fourth part. All right, so looking over the fourth part here, so you can see the method here, or the structure of this question is completely different from this one, and also from this one. So let's go ahead and look into this one. So now what is the first thing that we need to do here? So what is happening in this part here, or in this approach here? So this type of question here, we can see that we have two trig ratios, sine and cos. They are multiplying each other, right? They're multiplying each other. And then now we have sine squared on this side. So what does this mean? So if you have something like that, it means that here this is supposed to be a trinomial, right? In the sense that this first term must contain sine squared, and then this last term must contain cos squared. Now how do we change this one and write it so that it contains cos squared? So basically what we're going to do here is that we will first change 4, right, and write it as 4 times 1. All right, now why are we writing it as 4 times 1? Because we know that if we have 1 in an identity, we can equate that with sine squared theta plus cos squared theta. So now that's what we're going to do here. So we have 3 sine theta times cos theta minus 4, and then they will put in our sine squared theta plus cos squared theta. Now bear in mind that we didn't change the equation, we just manipulated it, right? And there's a difference, right? Manipulating it, it means it's still the same. Changing it, it means it's no longer the same, right? So here it's still the same. So now what do we get then from here? So from here, we see that we're going to get this part minus 4 sine squared theta minus 4 cos squared theta, right? Remember we said we wanted to have the 4 squared theta. So basically this minus 4 is going to subtract with that 5, and then we're going to be left with 1 sine squared theta plus 3 sine theta times cos theta, right, minus 4 cos squared theta equals to 0. All right, so when we get here now, how do we then solve for this, right? Now to solve for this, there are two ways, right? One way is we can basically take this, right, this value here, and write it according to the factors of 4, right? Or we can basically change sine theta like we did earlier. If this is too difficult for you, you can say let k to be equals to sine theta, right? If k is sine theta, then of course k squared is going to be sine squared theta, right? And then we can maybe say let w, because we also have another trig ratio there, to be cos theta. And then from there, w squared is going to be cos squared theta, right? Now by doing this, you can see that here you're going to have your k squared plus your 3kw, right, minus 4w squared equals to 0, right? I like it when it's like that because now you can see that everything now it is at ease, right? So once we get here, we can just factorize these two. So if you have two variables that you're trying to factorize, all you have to do is to treat them or look at it as if you have k squared minus 3k minus 4, right? Because you know that when you're having something like this, you can easily factorize this, right? So if you're having something like this, you know that your factors will be 1 and 4 minus and plus, right? Then now after doing that, you will just put in w after that, right? You're just going to put in w after that. So we said minus 4 like that. So you're just going to put in w here and w there, right? So now this is basically what we're going to be having here. So which means right here we're going to be having k plus w, because remember we're factorizing this now in terms of k and w. So k plus w, and then k minus 4w, right? Then this is equals to 0. So with this part, you can see that k plus w equals to 0, and that means k is equals to minus w. Now we know what is k, we also know what is w, or k minus 4w equals to 0, and so k is equals to 4w. Now, what is k? K is sine theta. So sine theta, first part, it means sine theta is equals to minus cos theta, right? Now if you remember this, we did have something like that earlier on. We said that when we have something like that, when we have sine and cos, we need to change that into tan, right? So which means we do that by dividing by cos both sides. This cancels with that, and then we have tan theta as minus 1. What about the other side? K is sine theta equals to 4w, it is cos theta. So we're going to do the same thing here. Divide by cos theta, divide by cos theta, and then this cancels with that, and then here tan theta is equals to 4. Now starting with the one on the left, we can see that tan theta is negative on the second quadrant and on the fourth quadrant, right? So which means now if we want to calculate our reference angle, right, our reference angle will be tan inverse 1. Now notice that I won't say tan inverse minus 1. The reason for that is because this sign has already helped me to identify which quadrants to locate, which quadrants am I going to be doing my general solution, right? So now that we have that, we're going to be having this part, and then when I press it on the calculator, so tan inverse of 1, it gives me 45. So which means my reference angle on this side is going to be 45. And then now second quadrant has a reduction of 180 minus reference angle. So the general solution there now will be theta equals to 180 minus 45 plus 180k, where k is an element of integers. So which means theta now is going to be 135 plus 180k. And then now we're going to look at the fourth quadrant. Fourth quadrant, it is 360 minus your reference angle. So with this one here, theta will be 360 minus my reference angle, it is 45 plus 180k, where k is an element of integers. Then from here, theta, it is going to be 315 plus 180k. Okay, so now here I'm going to go into the next part. Next part here, we have an answer that is positive. So positive is in the first quadrant and in the fourth quadrant. Now please don't think that this is going to be an error, because 10 doesn't have an error when the value is 4, so which means now we're just going to be calculating this 4, right? And then it means it's going to be a value that is going to be normal. So normal 1, 4, so we're getting 75,96. 75,96. Let me just go back there. 75,96. And so our first quadrant will be our reference angle, and so the reduction there will be theta equals to 75,96 plus 180k, where k is an element of integers. And then in the third quadrant, did I say fourth quadrant here? No, third quadrant, that's where 10 is positive. So in the third quadrant, it is 180 plus a reference angle. So from here we have theta equals to 180 plus 75,96 plus 180k. So theta is equals to, I go to the calculator and add this with 180, then it gives me 255.96, 255.96 plus 180k. All right, so now I'm going to be going over the last part, or the last approach of our general solution type of questions. All right, so looking over the last part, you can see that in this question, this is completely different from all of the questions that we were given there. So now here we are given cos and sine, but then the angles inside here are different. If you're checking on other questions that were given there, we're dealing with theta on each and every trig ratio. You see here, theta. Here it was just one trig ratio, which was say theta plus 2 degrees. All right, so with this one here, we're having something that is different. We have sine and cos, and then they have different angles there. So what is the approach of this one? So approach of this one is that you're supposed to have both trig ratios in both sides, right? So here I have cos already, so which means I need to change sine and write it in terms of cos. So how do I change sine? So I'm going to write sine according to a cofunction, right? Or using cofunctions. So I have theta minus 20 here, so which means now what I'm going to do here is I'm going to change this into cos 90 minus theta plus 40 degrees, right? So by having it like this, I can see that now that I have both trig ratios, right? Okay, so now here what I'm going to do after this is I'm going to simplify, and then I'm going to simplify what's inside that bracket there, or the angle that is inside there. So this is going to be minus theta minus 40. So let me just simplify one more time, and then from here we're going to continue with this method here. So 90 minus 40 is 50 minus theta. All right, so now we're sitting at this. Now you see here, now both of them are equal, right? But the angles are still different. So now what are we going to do here? So what we're going to do is we're going to take this angle that we have here, right? And then we're going to use it when we're calculating our general solution, right? And then we're going to take this angle here, we're going to use it as our reference angle. Then now remember earlier we're talking about the sine, right, of this trig ratio. Remember this is positive, so it means now we're going to ask ourselves in which quadrant is the trig ratio cos positive. So we know that cos is positive in the first quadrant and the fourth quadrant. So you're going to be using that when you're writing our general solution. So now what are we going to do after this? So now we want to say, now usually once you get to this part, your next step is your reference angle, right? So which means the reference angle here, I won't say it is cos inverse, I will just write the angle that is inside there, which is 50 minus theta. Then from there I'm going to go straight into my first quadrant. First quadrant is the reduction of reference angle, so which means now here I'm going to go to general solution. What is general solution? It is this angle, which is theta minus 20. So theta minus 20, it is going to be equals to 50 minus theta plus, and then the period for cos is 360k, where k is an element of integers, and then I'm going to solve for my theta. Take this minus theta, bring it across, gives me 2 theta. This minus 20 across, it gives me 70 plus 360k. Then I divide by 2 both sides, like that. And then theta becomes 35 plus 180k, right? So that is the first part. And then the second part, it is on the fourth quadrant. Remember, it is 360 minus reference angle. So that is what? That is the reduction there. So general solution, it is theta minus 20 equals to, and then now here we have 360 minus the reference angle, which is 50 minus theta, plus 360k, where k is an element of integers. And then now here I have theta minus 20 equals to 360 minus 50, which that will give me 310, plus theta plus 360k. And then I take the theta across, so I'm going to have theta minus theta on this side. And then now on that other side, I'm going to have 360 minus 50 is 310. But then I take the minus 20 across, give me plus 20 plus 360k. And then theta minus theta is what? Is 0, right? But then this is equals to 330 plus 360k. Now notice something here. Here we have 0. We have 0 being equals to 330 plus something into k, where k is an element of integers, right? There's no way that we can have this as true, right? So basically, this theta cannot, the 0 cannot be equal to 330 plus 360k, right? Remember, here this k is an integer, right? So because of that, they cannot be equal, right? Because of these cannot be equal, it means now here there won't be a solution. So what does this mean? So this means now the final answer for this one is theta equals to 35 plus 180k, and that is going to be our solution for this one. Now notice that these are all the type of questions that you're going to be getting. Now I understand that there are also grade 12 learners. When it comes to grade 12 learners, it is still the same thing, but then now the manipulation that has happened, that they included double angles and double angles and the compound angles and all those new identities there. But the nature there is that it's still the same thing, because once you start applying them, it will take you back into this one. So this is the first thing that you might help you towards your exams that you're going to be writing, and I hope you do well and good luck. Please make sure that you don't forget to leave a comment, and then if your friend, you feel like they're also going to be in need with this, share this with your friends or anyone that is not even your friend or a part of your YouTube community or your Facebook community. Make sure that you share this with them so that they can also be able to pick this up. And also don't forget to practice this on your own. Use this video, pause the section that you're going to be dealing with, look at the question and see which one is it similar to, understand how I did this, and then after that, make sure that you actually replicate what I did. And then that is the only way you can basically learn how to do this thing, right? In the next video, what I'm going to do is that we're going to be showing you methods of how you can basically apply identities. So I'm going to see you onto that one.